So far, we have seen that to indicate the logic level 0 or 1, we use the voltage value 0 volt or 5 volt. But in real life, it may be possible that the 5 volt is not exactly 5 volt. There are some variation. For example, 4.5 volt may vary from 4.9 to volt to 5.1 volt, or the variation may be even higher. The variation can be from 4 volt to 6 volt. So if there are variation like this, then will the circuit behave in the same way as we have seen before? For example, let's consider the circuit diagram of the logical OR operation. It was something like this. Now when the Vx1 and Vx2 both have voltage value of 5 volt, at that time we have seen that if we consider the current is passing across both of these diodes, then the current across this resistor will be in this direction, and the current to flow through the resistor in this direction, Vy needs to be greater than or equal to 0 volt. Now if Vy is greater than or equal to 0 volt, then for both diode D1 and diode D2, the anode voltage is 5 volt and cathode voltage is greater than or equal to 0 volt. That is, for both diodes, anode voltage will be higher than the cathode voltage, that is D1 and D2, both will be on. And when both diodes are on, we can represent these diodes with short circuit, and if these are represented with short circuit, then Vy will be directly shorted to this terminal at this terminal, that is, the circuit will look something like this. And then we can say both of these have voltage value of 5 volt and this is Vy. As both are shorted, we can say Vy is equal to 5 volt. Now what will happen that if this point has a value 4 volt instead of 5 volt? If suppose this has a value of 4 volt, will the circuit behave in the same way? Let's find out. Now let's consider the circuit where Vx1 has value of 4 volt and Vx2 5 volt. Now if both diodes are conducting, that we consider that current is flowing through both of these diodes, then the current across the resistor will be in this direction. And we know that current flows from high voltage to low voltage. So the voltage of Vy needs to be higher than or equal to 0, greater than or equal to 0 than the ground potential, so that the current across the resistor flow in this direction. Now if Vy is greater than equal to 0, then for D1 we can write that the anode voltage for D1 is Vx1, that is equal to 4 volt, and cathode voltage is Vy, which is equal to greater than or equal to 0 volt. So D1 will be on as anode voltage is greater than cathode voltage. For D2, anode voltage that will be Vx2, which is equal to 5 volt. Cathode voltage is again Vy, which is greater than equal to 0 volt. So these diodes will be on. Now if we represent both of these diodes with short circuit as both of them are on, then the circuit will look something like this. Now if the circuit look like this, then this has a potential 5 volt and 4 volt, and this is the output terminal Vy. Now as we see that both of these terminal have been shorted to this terminal, and Vy is connected to 4 volt and 5 volt. So what will be the voltage of the Vy, 5 volt or 4 volt? Now as you can see that Vy is shorted to both 4 volt and 5 volt. So these three terminals, as all of these are shorted, these act as one node. So all of these must have the same voltage value, but this is not the case. These two terminals already have different voltage value. So it is not possible for a node to have two values simultaneously. As these are all shorted, so these will act as one single node, and this is 4 volt and this is 5 volt, and one node cannot have two voltage values simultaneously. So this is not possible that both of these diodes are conducting. Now Vy will have a value of 0 volt, of 4 volt or 5 volt. Which of these values will Vy actually have? Let's find out. As both of these diodes cannot be on together, because at that time Vy and 4 volt and the 5 volt will have the same voltage, which is not really possible. So other 3 cases, that is D1 is on, D2 is off, or D1 is off, D2 is on, or both of these are off, from these 3 cases one must be the case. Let's find out which one is the actual case. Now let's consider that both diodes D1 and D2 are off. If both are off, then we can represent both with open circuit. So our circuit will look something like this. Vy. If both are off, then the current across this resistor will be 0, this diode will be 0, this will be 0. So the current across the resistor will also be 0. As VR is equal to Vy minus 0, so Vy is equal to VR, that is I times R, as I is 0. So the voltage of Y will also be 0. Now if Vy has a voltage that is equal to 0, so I can write that Vy equal to 0 volt here. So you can see that the voltage of diode D1, the anode of diode D1 is 4 volt and cathode is 0 volt. So anode voltage is higher than the cathode, but I am assuming that the diode is off. Is it possible? No. Again for diode D2, anode is 5 volt, cathode is 0 volt, but I am assuming that D2 is off. So I am assuming that both diodes are off, but it is proven that anode voltage is greater than cathode voltage in this case. So this is not possible. It is not possible that both diodes are off. So this leaves 2 cases, that either D1 is off or D2 is off. Now let's explore those. Now let's assume that the D1 is on and D2 is off. If this is the case, then we can represent D1 with short and D2 with open circuit. So this is 4 volt and this is 5 volt and this is our output terminal. Now as you can see that the output terminal Vy and 4 volt is shorted, so this time Vy will result in 4 volt. Now if Vy is 4 volt, you can see that this is the diode D2, right, and this is Vy, which is equal to 4 volt as we have found here. So Vy here, that is the for D2, the cathode voltage this point is 4 volt, anode voltage this point, that Vx2 is 5 volt. So anode voltage is greater than cathode voltage, but we are assuming that D2 is off. So we can see that this is also not possible. So that leaves us with only one option, that is D1 is off and D2 is on. Let's analyze that circuit. So this time I am assuming that D1 is off and D2 is on. If this is the case, then I can represent D1 with open circuit and D2 with short circuit. So this is 4 volt, this is 5 volt, and this is our resistance R, output terminal Vy. So now for this circuit, as you can see, Vy is directly shorted to 5 volt. So Vy will have a voltage 5 volt. Now if Vy has 5 volt, that I can write Vy equal to 5 volt. Then for D1, anode voltage is Vx1, which is 4 volt. The cathode voltage Vx2, cathode voltage Vy is 5 volt. So anode voltage is less than the cathode voltage for D1. So the diode is off. So as we can see that we have assumed D1 to be off and D1 is indeed off. So this is the case. So we can say that for the logical OR operation, for that circuit diagram, when my input voltage have different values, one have 4 volt, one have 5 volt, and if there are, let's say there is another diode
which may have a value of 3 volt. If there are multiple values, then the voltage source that has the highest value, this time that is the 5 volt, will be equal to the output voltage. You can also analyze this circuit, that here I have considered 3 diodes D1, D2 and D3. Here, as there are 3 diodes, there can be 8 combination. There can be 8 combination, and if you do analyze the circuit, you will find out that only when that this diode is on, the diode with 5 volt is on and other 2 are off, only then the conditions will be satisfied. Other than that, all for other 7 combination, you will find that your assumption was wrong. So for OR operation, when there will be multiple inputs with multiple input voltages, at that time the output voltage will be equal to the voltage of the input that has the maximum value. Now this was the case for OR operation. Let's see what happens when we consider AND operation. Now this is the circuit diagram of logical AND operation. Say Vx1 has a value which is equal to 0 volt and Vx2 equal to 1 volt. What will happen? Now say I consider that D1 and D2 both are conducting. If both are conducting, D1, D2 both are on. At that time we can represent both the circuits with short circuit. If both are represented with short circuit like this is our output terminal. Represent with short circuit like this, 0 volt and 1 volt. This is our output volt. So again we can see that here these three, that these are shorted. So these are actually one same node, and one same node cannot have different values. So this is not possible that both diodes are conducting. Let's consider D1 and D2 both are off. If both are off, then we can represent them with open circuit. Now if both are open, then the current across this will be 0. Also this will be 0. The current here will also be 0 ampere. So if this is 0 ampere current, so this time Vy will be 5 volt. Now if this is 5 volt, that is if you consider these two, then Vy is 5 volt. Then for both D1 and D2, the anode voltage is 5 volt and cathode voltage for D1 it is 0, for D2 it is 1. But for both diodes, anode voltage is higher than the cathode voltage. But we are assuming D1 and D2 are off. So it is not possible that when the anode voltage is higher than the cathode voltage, then the diode is off. So this case is also not possible. Now let's consider the case where D1 is off and D2 is on. If this is the case, then I can represent D1 with open circuit and D2 with short circuit. So if this is the case, then Vy, as it is directly shorted with the 1 volt terminal, so I can say Vy is equal to 1 volt. Now if Vy is equal to 1 volt, then for diode D1, I can say that the anode voltage Vy is equal to 1 volt. This is the anode voltage. Then for diode D1, the anode voltage is 1 volt and the cathode voltage is 0 volt. So anode voltage is higher than cathode voltage, but I am assuming D1 is off. So this is again not possible. So this leaves us with the last case, that is D1 is on and D2 is off. Now if I consider this, then we can represent the circuit in a way that is 5 volt R, diode D1 is shorted this time as it is considered on, and D2 open. So this is 0 volt, this is 1 volt, and this is our output. So as 0 and 0 volt and Vy is shorted, so Vy will be 0 volt. Now if Vy will be 0 volt, then for D2 I can write that for D2 the anode voltage is 0 volt and the cathode voltage is 1 volt. So anode voltage is less than the cathode voltage, as assumed it will be off. So this is the case. So from this we can see that for the logical AND operation, when different voltage sources have different value, that is Vx1 and Vx2 have different value, at that time the output will be equal to the minimum voltage. Here 0 volt and 1 volt, so this time output will be equal to the 0 volt, as 0 Vx1 is the minimum as we have found out here. Now if there are more than 2 diodes, for example, the circuit would have been something like this. For say 3 diodes with value, for example, 0 volt, 1 volt, 2 volt. In this case, there can be, as there are 3 diodes, so there can be 2 to the power 3, 8 possible combinations. But among this 8 combination, since among these 3 values, this is the minimum value, output will be 0 volt. So when D1 will be on, D2 and D3 both will be off, only then the circuit conditions can be satisfied. Without except this one condition, for all other 7 combinations, you will see this the conditions of your assumption for the diode won't be satisfied. You can work this out and find out by yourself. As you have seen that in these cases where D1, where the input voltages have different value, we have analyzed the circuit considering different scenarios. Sometimes we have assumed that D1 is on, D2 is off. Again, we have considered D2 is on, D1 is off, all the possible combinations. So we do not actually know what may happen. We have considered different scenarios. This is called method of assumption or method of assumed state, you may also call this. This is a very useful technique while doing the analysis of multiple diode circuits, because for multiple diode circuits it is always not possible to say whether the diode is on or off. That is, if you look in the IV characteristics of an ideal diode, you have seen it is something like this. So it is possible that our load line may intersect the curve at this point or this point. We do not know. We have to assume this region or this region. Method of assumption is a very common technique and a very useful technique for solving this type of diode circuits. How this is used, we will look into this in details in the next lecture. Thank you.